Hello, grade 10s. In today's lesson, we're going to complete this chapter of revision of matter and classification. We ended off the last lesson on this slide, and I told you that this is the periodic table that you will be receiving all the way to matric. So you need to be really familiar with it. Now, let's take a look at the key over here. This periodic table gives us the symbol of each element. The periodic table doesn't give us the names of the elements. I'd like to take you through all the elements that you need to be familiar with on the periodic table. The other thing I'd like to bring to your attention is, as per the key, you have the atomic number at the top of the periodic table. You've got the approximate relative atomic mass. Now, you should be familiar with the fact that this value at the bottom is the atomic mass, but we will understand later on why it is considered the approximate relative atomic mass. And the number on the left-hand side of the element represents the electronegativity of the element. Now, we're only going to learn more about electronegativity in grade 11, but there will be one mention of electronegativity in grade 10, so please just keep this number in mind. So let's go over the periodic table, and let's go over all the elements whose full names you need to be familiar with. So we need to be familiar with the names of all period 1, 2, and 3 elements. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon, sodium and magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. In period 4, we have potassium and calcium, chromium, manganese, iron, cobalt, nickel, copper, zinc, arsenic, bromine, krypton. Let's move on to period 5, and here we should be familiar with Ag, which is silver, and we have iodine. Period 6, barium comes up very often. We have platinum, gold, mercury. We have lead over here. I also left out element number 15, period 5, which is tin. And down here, just be familiar with U, which is uranium. It's a very common element that we come across. So you should be familiar with the names of all the highlighted elements because it is not given to you on the periodic table that you'll be given all the way to matric. So now we can move on to the names and formulas of chemical substances. Elements have chemical symbols and elements have names as per the periodic table. So, for example, Mg is the chemical symbol for magnesium, and O is the chemical symbol for oxygen, and magnesium and oxygen are the names. Now, chemical formulas of compounds obviously use the chemical symbols of the elements that make up the compounds. And chemical formulas also represent the ratio in which these elements bond. So, for example, if we look at the chemical formula MgO, well, this is a compound that is made up of one magnesium atom and one oxygen atom. Chemical names of compounds identify the names of the elements that make up the compound. So, based on the name magnesium oxide, we may identify that in that compound there is magnesium and oxygen atoms. Now, some compounds also have common names. So, magnesium oxide is often commonly known as magnesia or milk of magnesia, which is the active ingredient in antacids. Those are the medicines that help us relieve the symptoms of heartburn. It's a type of base. Let's take a look at a few more examples. We should be familiar with these compounds, their common names, and their chemical names. H2O is water. The chemical name, as we'll learn to name it now, is dihydrogen monoxide. NaCl is salt or table salt. Now, there are lots of different types of salts. Table salt we refer to as the salt that we eat every day, and the chemical name for that is sodium chloride. NH3 is ammonia. The chemical name is nitrogen trihydride, but we need to be familiar with the common name and the chemical formula of ammonia slash NH3. Now, ammonia is used in cleaning detergents, such as an oven cleaner, and it is a base. CH4 is methane. The chemical name is carbon tetrahydride, but again, we need to be familiar with this chemical formula and with a common name. CH4 is an organic compound, meaning that it is created by living things. It is found in cow flatulence, and it is actually a contributor to the greenhouse effect because this is a very potent greenhouse gas. There are millions of different types of compounds and molecules in the world, therefore there are millions of names. Unfortunately, many compounds were named a long time ago before it became obvious to scientists that they need some sort of systematic method for naming. And then, even once systematic methods were developed, they kept on changing over the years. So that has added a lot of confusion to the names of compounds over the years. What we're going to learn now is obviously the latest method of naming compounds. We're going to start off by writing the chemical formula given a chemical name. What is a molecular compound? Well, a molecular compound is made up of only non-metals. You really need to keep that in mind. When you see the word molecular, think of non-metals. Semimetals fall into the same category. So if the compound is made up of non-metals and a semimetal, that's still a molecular compound. And one very important thing that we haven't learned yet, and we'll learn it later on in this topic of matter and material, is that molecular compounds that are made up of nonmetals, chemically bonded, semimetals may be involved, have a specific type of bond that holds them together, and that is called a covalent bond. We haven't learned this yet, but keep it in mind for now. So as a first step, we represent each kind of element in the compound with the correct symbol for that element. So if I give you the name dihydrogen monoxide, well, the hydrogen tells you that there is H, and the oxide tells you that there is O in that compound. And as a second step, we use the subscripts, which are small and lowered numbers, to indicate the number of atoms of each element in that compound. So di represents the number 2, and mono over here represents the number 1. So that tells it that there are 2 hydrogen atoms and 1 oxygen atom. Mono represents 1, di represents 2, tri is 3, Tetras 4, pentas 5, hexas 6, heptas 7, and octa is 8. So in this case, dihydrogen monoxide will be H2O. Note that it's not H2O1. We just leave out a 1. So if there's no number next to the element in the compound, that represents that there is one of that element in that compound. The order in which the elements in a molecular compound are displayed follows a bunch of rules, but there are also lots of exceptions. You don't have to worry about it because you are just going to place the elements in the same order as the name. But just to be aware that hydrogen usually comes first in a molecular compound. Remember, molecular compounds are made up of nonmetals. Now, when carbon's involved, carbon will always come before hydrogen. And the other rule is that generally the element that is in a more metallic position, and we learned that if you look at the periodic table, a more metallic position will be further to the left and further to the bottom of the periodic table. Well, that element will come first in a molecular compound. So nitrogen is in a more metallic position relative to oxygen. Sulfur is in a more metallic position relative to oxygen, so they come first in the compound formula and in the compound name, keeping in mind, of course, that none of these elements are actually metals. Let's take a look at some examples. Dihydrogen monoxide is H2O. Di means 2, mono means 1. Whereas dihydrogen dioxide, again, there's hydrogen and oxygen in this molecule, but there is di, 2 hydrogens, and di, 2 oxygens, so it is H2O2. Carbon disulfide. Well, carbon's the first element, and the second element is sulfur. There's 1 carbon, and there are 2 sulfur atoms in this compound, so it is CS2. Diphosphorus tetraiodide. So we have phosphorus and iodine. We have 2 phosphorus atoms and 4 iodine atoms, so it is P2I4. Let's now look at how we would name molecular compounds that are made up of only 2 types of elements, both of which are nonmetals, or a semimetal and a nonmetal. So remember, these are molecular compounds made up of nonmetals. Semimetals fall under that same category when it comes to naming methodologies. And keep in mind that the bonds between those are called covalent bonds. Let's take a look. So we're going to use this method for molecular compounds that contain 2 nonmetals or a semimetal and a nonmetal. So it may only contain 2 types of elements. Otherwise, there's a different naming methodology. So this is a naming methodology specific to 2 types of elements that are both nonmetals or a semimetal and a nonmetal. Step 1, we name the elements in the order that they appear in the formula. Step 2, the second element, its name is going to end in I. So we're going to drop the last, sometimes last two syllables of that element and end the name of that element in "ide." And then step 3 is we're going to use the prefixes like mono and di and try to indicate the numbers of atoms of each element in the molecule. So let's take a look. So if we have CO, that is carbon monoxide. There's 1 carbon and 1 oxygen. The oxygen, its name changes to end in "ide," so it becomes oxide. What we need to realize here is that we don't include mono for the first element. So we won't call this monocarbon monoxide. It is simply carbon monoxide. CO2, there's carbon, one carbon atom, and there are two oxygen atoms. Again, we won't call this monocarbon. We leave out the mono for the first element, but the second element, there are two of them, there are two oxygen atoms, so it's a di, and oxygen changes names to oxide. Let's take a look at C2H4. Now, in this case, it's going to be dicarbon because, like I said, we only leave out the mono prefix for the first element. But if the prefix is di or tri or tetra for the first element, we don't leave it out. Now, H is hydrogen, and that is going to change names as the second element to hydride, and there are 4 hydrogen atoms. So this would be di, and this would be tetra, and the name is dicarbon tetrahydride. pH3, there's one phosphorus atom, so we won't include the mono, but we've got 3 hydrogen atoms, so it is going to be phosphorus trihydride. Let's look at this example over here. Silicon is a semi-metal, but remember that the naming methodology is exactly the same. We have 2 silicon atoms and we have 6 chlorine atoms. Chlorine is going to change names to chloride. So what we have is disilicon, because we've got 2 silicon atoms, hexachloride. Hexa represents 6, and we've got 6 chlorine atoms within this compound. The next naming methodology is naming ionic compounds. Now remember that previously we looked at molecular compounds. We said that molecular compounds are made up of nonmetals. Semimetals fall into that category. Ionic compounds, on the other hand, are made up of metals and nonmetals. So when metals bond to nonmetals, that is actually called an ionic bond. So keep that in mind again. We haven't learned it yet, and we're going to get there later on in this topic. Now, this particular naming methodology applies to an ionic compound that is made up of one type of metal and one type of non-metal. So it can only be made up of 2 different types of elements. Again, otherwise, there's a different naming methodology, but we're focusing on just a few. So let's take a look. As step number 1, we're going to name the elements in the same order as they appear in the formula. In this case, the metal always comes first because a metal is always more metallic than a non-metal. And as step 2, the second element's name ends in "ide." So step 1 and step 2 of this methodology is exactly the same as step 1 and step 2 of the previous methodology, where we named molecular compounds made up of 2 nonmetals. But this is where this ends. So in this case, when it comes to ionic compounds, whenever a metal is involved, we don't use the prefixes. We don't use dis and tris and tetras and hexas. So no prefixes are used. Let's take a look. CaS is calcium sulfide. Na2S is sodium sulfide. So note that there's no monos and there's no dis. However, the second element does change names to end in "ide." Li3N, again, the fact that there are 3 lithiums, that's not going to be mentioned in the name in any way. It is lithium, and then nitrogen changes name to nitride. Fe2O3, this is iron, and oxygen becomes oxide, so it's iron oxide. And the last naming methodology that we're going to learn is again ionic compounds. These ionic compounds are made up of one metal and two nonmetals. But one of those nonmetals has to be oxygen. So this naming methodology only applies to instances where there is a metal and two nonmetals, one of which is oxygen. Step 1, we want to name the elements in the order that they appear in the formula. Again, the metal comes first. Step 2, in this case, we drop the oxygen from the name altogether, but we take the other nonmetal, and that nonmetal's name will end in ate. So if you see a compound whose name ends in ate, that automatically tells you that there is an oxygen in that compound. For example, CaCO3 is calcium carbonate. So the oxygen's name is not featured, but carbon changes to carbonate, and this ate tells us that there is oxygen in this compound. Again, note that the naming doesn't indicate the number of the elements, the ratio in which they bond. So we don't have dis and tetras and hexas whenever there are metals involved. K2SO4, this is potassium, and sulfur changes names to sulfate. Al2CO33, don't let the brackets confuse you. We have a metal, aluminium, and carbon changes name to carbonate. So it's aluminium carbonate. Ba3PO42, barium, and phosphorus is going to change names to phosphate. So it is barium phosphate. Has two exceptions to it. So the first exception is when we have a metal bonded to two non-metals, one of which is oxygen, but the other one is hydrogen. That is always going to end in an OH group, and that is called hydroxide. So in this case, the compound's name will actually end in "ide," even though it contains an oxygen atom, but we need to be familiar with the fact that the hydroxide group is OH. The other exception to this rule is the fact that we have the existence of NO2 and NO3. We also have the existence of SO3 and SO4 over here. Now, let's say lithium was bonded to NO2. You would then want to call it lithium nitrate. And if lithium is bonded to NO3, you'd also want to call it lithium nitrate. But two compounds with different chemical formulae cannot possibly have the same name. So what did scientists decide to do? They decided that the compound that is made up of fewer oxygen atoms won't actually end in ate, it will rather end in ite. So in the case of nitrogen and oxygen bonded to each other, NO2, well, that's two oxygen atoms bonded to the nitrogen, so that gets the name nitrite. And because NO3, which is commonly existing, has got more oxygens bonded to it, this one will end its name in an ate, so it will use the original naming methodology. So lithium bonded to NO2 will be called lithium nitrite. Remember, this is a T, not a D. And lithium bonded to NO3 will be called lithium nitrate. Same goes for the sulfurs here that are bonded to oxygen. SO3 and SO4 are very commonly existing, but here 4 is a larger number than this 3 over here. So SO4 gets the 8, whereas SO3 will get the 8. So let's say we've got aluminium bonded to SO3. Well, that would be called aluminium sulfite, and aluminium bonded to SO4 will be called aluminium sulfate. And these are the only two exceptions that you need to be familiar with. And we're going to go over it again a little bit later when we are introduced to the table of ions. So let's take a look at some examples. NaOH is sodium hydroxide. Remember that the OH group is always called hydroxide, and when you see hydroxide, you should immediately think OH. So AlOH3 is going to be aluminium hydroxide. KNO3 is potassium nitrate because this is the O with 3 atoms of oxygen, whereas here where we only have 2 atoms of oxygen, that gets the 8. So that is potassium nitrite. And the same goes for the SO4s and SO3s. The SO4s get the 8. So this is going to be aluminium sulfate, whereas this over here, which has got 3 oxygen atoms, which is a smaller number than the 4 over here, is aluminium sulfite. The last thing we need to do is just practice some of these. So I would like you to pause the video before you replay it to look at the answers. But please try these on your own to see how much of what we've just learned about naming compounds you have grasped. So let's take a look. Sulfur triiodide is Si3. Sulfur trioxide is SO3. Nitrogen monoxide is NO. Remember the use of capital letters, and when you write out these chemical formulas, make sure that your capital letters are clearly capital letters. Carbon disulfide is CS2. Carbon monoxide is capital C, capital O. Nitrogen trihydride is N for nitrogen, and we've got 3 hydrogen atoms, so it's NH3. Silicon dioxide, silicon is a semimetal, but it follows the same naming methodology as nonmetals, so it's SiO2. And boron trifluoride, again, we're dealing here with a metalloid or semimetal, but the naming methodology is the same as for nonmetals, and this is going to be BF3. So note that all the examples we've looked at now are all examples of nonmetals, where we do include our dis and our tris and our tetras and our monos. But again, remember that we just don't include mono for the first element if there's just one of them. So we wouldn't call this mono carbon monoxide. We leave out the mono prefix for the first element. Let's look at the chemical names of the following compounds. So CO2 is carbon dioxide. SO2 is sulfur dioxide. NO3 is nitrogen trioxide. CCl4 is carbon tetrachloride. Again, these are all nonmetals, so we've got the inclusion of our dis and tris and tetras. But here we have NaCl with Na being a metal and Cl chlorine being a nonmetal. So this is going to be called sodium chloride. We're not going to say sodium monochloride because the moment we deal with a metal, we don't do monos, dis, tris, etc. CuO, Cu is copper, O is oxygen, so it is copper oxide. MgS, We've got magnesium and sulfur, so that is magnesium sulfide. MgF2, again, this 2 over here is not going to feature in the name at all. The only thing that's going to feature in this name is the existence of the magnesium and the existence of fluoride. So it's going to be magnesium fluoride. Fe2O3 is simply iron oxide. CaCl2 is calcium chloride. CuCO3, now we're dealing with a metal and two nonmetals, one of which is oxygen. So these names are going to end in 8. So this is going to be copper for Cu and then carbonate for the CO3. NaNO3 is sodium, and nitrogen is going to change names to nitrate. So it is sodium nitrate. CuSO4 is copper. Now be careful. SO4 is the one with the more oxygens. So it is copper sulfate. KClO3, well, here we've got a metal. Here we've got a nonmetal chlorine bonded to oxygen. So that is going to be potassium chlorate. So chlorine changes names to chlorate. NaOH, that is our exception with the OH group being called hydroxide. So it is sodium hydroxide. AlOH3 is aluminium hydroxide. And that brings us to the end of the first chapter of matter and material, which is revision of matter and classification. I suggest that you try the practice test and mark your answers against the memo to see how much of the section you've grasped.